Hi guys, welcome back to my channel. So in this video we will be solving this past midterm that I found online. So let's get started. So this is the first question that we will be solving over here. So let's see. So this is the first question. It says the position of a particle at time t is given by this vector function over here, and 1a, the question 1a asks us to compute the velocity and acceleration of a particle at any given time. So let's try and find this. So here we have our vector equation given as 2 over 3 t cubed I hat plus 3t j hat plus square root of 3 t squared k hat. And now to find the velocity, we simply need to take the derivative of the vector function, because this derivative represents the position, and if you take the derivative of the position, it gives you the velocity. Okay, so this is also the velocity if you take the derivative of it. Okay, so let's go ahead and take the derivative of it, and I hope you guys remember taking the derivative of a vector function. So we take it component by component. So first we take the derivative of the I component, and then j component, and lastly the k component. So let's go ahead and do this. So here, this t is to the power of 3. So then this 3 is going to come down. Okay, so it's going to multiply by this constant over here, 2 over 3. And then we're going to subtract 1 from it. So it becomes t squared I hat. So now moving on to the next component, which is 3t. So it's going to become t3 only. Okay, next we have this square root of 3, that's a constant, and this, so then 2, it's gonna come down and it's become 3. So if you just write it neatly, it's gonna be 2 t squared I hat plus 3 j plus 2 square root of 3 t k hat. And this is our velocity equation. So let's go ahead and solve for 1b now. Okay, so what does 1b ask us to do? So the one, we're done with 1a. Now for 1b, find the total distance traveled by the particle from 1 to a. Oh wait, we're not done with 1a yet. It asks for the acceleration as well. We haven't found acceleration yet. So let's go ahead and find acceleration. And how do we find the acceleration now? So to find the acceleration, we can simply take the derivative of the velocity, or we can take the double derivative of the displacement to get the acceleration. Okay, so we're going to take the double derivative, which means we take it single and then we take it again. So which is the same thing as taking the single derivative of the velocity. So we have velocity over here. So let's take the single derivative of this in order to obtain the acceleration. Okay, and remember I already explained you guys all this in my previous videos. Okay guys, so like I said, I have already explained you guys these things. So if you go over my channel, search for this video, you will find I've already explained
give us the
how to
we
find
can
velocity and acceleration.
you have to know that,
and I also did some problems. So if you want to check that out, you can check it out. The link is
messing
in
up
the
things.
description below. Do check the playlist.
Okay, now
Let's move
minus
on to the
2,
problem now.
and what's the
Okay, so here we're finding for the double derivative of this one. So we're taking the derivative of this again. So taking the derivative of this again by component. So here we have 2t squared. This is gonna be 4t. If this 2 comes down, so it's gonna be 2 times 2, then it's 4t I hat plus, this is a constant, so the derivative of a constant is 0, so 0 g hat plus, it's a t in front, and only constant remains over here if we take the derivative of it. So this is the derivative of the acceleration. So this is how you got the acceleration vector. So now finally our 1a is done. We have calculated for velocity and acceleration. So we can finally move on to 1b. Oops, we haven't done yet. Why am I crossing it out? Okay, so for 1b, we need to find the total distance traveled by the particle from time 1 to 2. To find the total distance traveled, So what we need to do is we need to take the derivative of the vector function, the first derivative of the vector function, and magnitude it, and then we're going to integrate it from 1 to 2 from the time given. Okay, so this is what we're going to do. So how do we calculate for the first derivative? So if you guys can see, we already calculated for the first derivative, r prime of t, we already get it. We simply need to find the magnitude of it. So let's go ahead and find the magnitude of it. And how do you find the magnitude of it? We're going to square each component and then square root the whole thing. So squaring each component, okay, and then 3g, so 3 squared plus 2, 3. Okay, now we're gonna square root the whole thing. So what does this give us? So this is going to become 4t to the power of 4 plus 9 plus, and you might be thinking, how do we do this? So for this, just remember, so when you're taking the square root of square, so the square root and square, they cancel out each other, and you have a 2 in front. So when these two cancel out, so you're not left, you don't have this square root and square anymore. They cancel out each other, so you only have 2 times 3, which is equals to 6. Okay, so this is how you're gonna do it. Oh wait, this is not 3, this is 4, because you're squaring it, right? So wait, let me do this again. So this square and this square, they're gonna cancel out each other, okay, for this one, but this square also applies to this one, so that's gonna be 4, and then you have 3, so 4 times 3, that's 12. Okay, now it's good. So now this is 12. Okay, oh my bad, I forgot to write the t over here. It has to be a t over here, so then this t squared, so that this has to be t squared as well. Okay, so this is the equation that we get over here. And in this type of question, when you want to find the magnitude of the r prime of t, you always need to make sure that there's a way to factor this out so that you can remove the square root. You should be able to get this into square so that you can cancel the square root with the square. So let's try to factor this so that you can cancel out the square with the square root. Okay, for this, the first step is to writing this in order. So we're gonna move this 12t squared in here and then 9, and now we can square root the whole thing. Now to factor this, remember how do we factor? So when we have something like ax plus b plus c, sorry, ax squared plus bx plus c, so how do we do this? So we're going to multiply. We need to find 2 numbers such that if we multiply them, we're gonna get a times c. Okay, and if we add those 2 numbers, we need to get this b. Okay, so just like in here, so this is like ax squared plus bx plus c. So we need to find r and s, these 2 numbers, such that we multiply them. So it needs to give us a times c, which is 4 times 9, and 4 times 9, that's 36, and then 2 numbers that we add them so that it gives us 12, which is b, right? So what are these 2 numbers? So that we multiply them, we get 36, and if we add them, we get 12. So let's think about it. So if you think, so you'll end up with r equals to 6 and s equals to 6 and 6. Okay, so these are the 2 numbers. If you're going to multiply them, you're going to get 36, and if you add them, you're going to get 12. Okay, so next step is to break this 12 into 6 and 6 into r and s. We're going to write this in the form of r and s. We're going to remove this 12, so we're going to replace this with 12 6t squared plus 6t squared plus 9. Okay, so we are breaking this because it was 12t, now it's 6t and 6t. This is how it has to be, right? Next, what do we do next? So we're going to factor this again until we get square something. Okay, So now you're going to split these two, okay, and look at what can you factor from these, okay. So in here I can see that I can factor 2t squared from here, okay, 2t squared because it's common in here and it's common in here as well, okay. So if you factor this, so this should give you 2t squared, because if you multiply these it should give you 4t squared, right? And then here you should have 2 times 3, that's going to be 6. Yeah, so if you multiply this times this, it should give you this, right? And here I can see that I can factor out the 3 over here, because this multiplies by 3 and this as well. So then we have to do 3 times 2, which is going to give us 6, and then t squared. So 2t squared, that's going to give us 6t squared, plus 3 times 3, that's going to give us 9. So if we multiply these, it's going to give us this, right? All right. So what is our next steps? I'm going to remove these arrows that I made. Just wait, so you guys don't confuse yourself. Okay, so now what do we need to do? We're going to take these two and these two to be able to factor this out. So 2t plus 3, and then these two, since they're same, so we get 2t plus 3 as well. This is high school factoring, right? I hope you guys remember doing this. So these two have to be same, and we're gonna collect this, and it just happened to be in this case that these two happen to be same as this one. It's not usually the case, but it is the case when we have to put a square, right? I'm talking about the case when in the factoring, like when you factor, it doesn't have to be, these two doesn't have to be same as these one, but yeah, these two have to be same. Okay, so now we have 2t, we have these two terms. So if we have like, so suppose this is like x and this is x as well. So what is x times x? That's x squared, right? So just like that. So 2t squared plus 3 times 2t squared plus 3. So it's like multiplying by itself, which is same as 2t squared plus 3 squared. Okay? And yeah, not forgetting the square root, which was originally at the top. So now we can finally cancel out the square root with the square, and we are left with 2t squared plus 3 finally. Okay? Okay, so what are we going next? So we just found the magnitude of the r prime of t. Now this is 2t plus 3, right? Now we need to integrate this that we found, the answer that we found, with respect to 1 and with respect to dt, and from the interval 1 and 2. So let's go ahead and find the integral of this one, respect to 1 and 2, with respect to dt, and the limits of integration from 1 to 2. Okay, so we are integrating with respect to dt, which means here this is t squared, right? So we're going to add 1 to it and then divide it by this 3. And it's a constant, so we're going to put a t in front of it. Now we are going to solve this by plugging in 2 and 1. So first let's go ahead and plug in 2 inside this equation. Okay, and I'm going to subtract it by plugging 1 in this equation. Okay, so if you do this, it's going to give you 16 over 3 over here. This is going to be 6, and this is going to be 11 over 3. And if you solve all this, it should give you 23 over 3. And this is the answer to 1b then. Okay, so we just finished 1b as well. Now, find the tangential and normal component of acceleration for RT. So now we're finding the tangential component of acceleration and normal. And I have already explained you guys how to do this. Okay, here in this video that I have showed you guys tangential and normal acceleration, I have given you guys this formula to find the A tan, the tangential acceleration, and the normal acceleration. Okay, so first let's find A tan. So to find A tan, this is the formula. We're going to dot product the r prime of t with r double prime of t, and then we're going to magnitude it with r prime of t, which is same as, because r prime of t, it's same as velocity, and r double prime, like I explained before, it's same as acceleration, and here which is same as velocity. So we're going to take this formula and let's find it. Okay, so v dot a over v. Okay, so we have this formula over here, and we already calculated for v. Okay, let's check it out. Where is it? So we're gonna scroll up and check out where is the v. So v is over here, we calculated over here, so let's pick it up from here. And here, this is the acceleration, and let's pick the acceleration from here. Okay, so I just got this acceleration velocity that we found in the previous question. So now let's go ahead and dot product this velocity with acceleration. Okay, so how do we dot product? So to dot product, we're simply multiplying I hat with I hat, j hat with j hat, and k hat with k hat. Okay, so what do? We are going to multiply this together. So first let me write it all together. Let me show that I am dot producting. Okay, that I'm doing the dot product. Okay, now I can finally do this. So to dot product, what I'm going to do, I'm going to multiply this I hat times I hat. Okay. So this I hat times I hat, it's going to give us, so 4 times 2, that's 8 t cubed, plus you're going to, when you do dot products, I, j, and k cancel out, so you're not going to write it, and the whole thing becomes a sum. So you're going to add it, and then you're going to multiply j times j, and this is going to give you 0, so you don't need to write it. Okay, and then you're going to have this times this k hat times k hat. So again, this is gonna give you something like this, and like I explained before, it's gonna become 4, and this is gonna cancel out, so it's gonna give you 12. 4 3s are 12. Okay. I'm making a mess over here. Yeah, 12, and since there's a t as well, so it has to be 12t. Okay, now that you have dot producted, so this is the v dot product with a. Now you need to find the magnitude of v, and you need to divide it by the magnitude of v. Okay, so let's find the magnitude of v over here. So this is v. What's the magnitude of it? So we're going to square each component again. Okay, and then square root the whole thing. So what is going to give us? So it's going to give us 4t squared plus 9 plus 12t squared, and again you're going to follow the same step that we did over here, or you can simply write it from here. So here, remember we had to find the magnitude of r prime of t, and r prime of t is same as v, right? So here we actually calculated for the magnitude of v, so we don't need to calculate it again. Okay, so what did it give us? So at the end we got the result as 2t squared plus 3 as magnitude of v, or you can call this as r prime of t, right? Magnitude, so it's the same thing. So we can just write it over here. So we got our v as 2t squared plus 3. So now we can simply divide this equation by magnitude of v. So that's 2t squared plus 3. And this is the answer to A10. This is how you calculate the A10. Now how do we calculate for A normal?
Terms of the
So to calculate A normal, we have the formula. We're gonna cross product v times a over magnitude of v again. Okay, so we have this formula over here, v cross product with a over magnitude of a. So we're going to do the cross product. First we need to write in the form of I, j, and k. Okay, let me move to my white pencil again. I think it's better. Okay, now to cross product V and A, you need to make sure you write first V, not the A, or else it's gonna give you the wrong answer. Okay, so first of all, we're writing V. So what is V? So V is 2t squared plus 3t. So let's go ahead and write it over here. So we have 2t squared, 3, and then 2 square root of 3t. And next, what do we have then? So we have acceleration next. So the acceleration is, we write it at the bottom. So that's 4t. And then it's 0. And then it's 2 square root of 3. So now this is how we're gonna do the cross product of V times A. Okay, so this is simply the setting up of V times A. Okay, and in order to solve this, first of all, what you're going to do, you're gonna cross out the ith column and the ith row. So when you're gonna cross out this, you're gonna multiply by this times this, and then negative this times this. Okay, so you're gonna write the answer to this then. So remember, crossing out ith row and ith column, and then writing out the answer to this one. Okay, so 3 times this and 0 times this. Okay, so I am just gonna do all this. So remember, what I'm doing over here is simply multiplying this times this. So this is gonna give me 3 times 2, which is 6. So 6 square root of 3, and then negative this times this, that's gonna give me 0. So I don't need to write it. Okay, and then I had, of course. And remember, for the first one it's positive, for the second one it's negative, and for the third one it's positive. For the j hat it's always negative. So here we are in the I hat. Next we're gonna put negative j, negative, because we are in the j hat. So now we're gonna cross out the jth column and the jth row. So next we're gonna multiply this times this, and then negative this times this. Okay, remember, this times this, and then negative this times this. Okay, so I'm gonna do everything again. So this times this, so this is gonna give us 4 square root of 3 t squared, and then we have negative this times this. Okay, that's gonna be 8 square root of 3 t squared. Okay, and then this whole thing belongs to j hat. Next we have a positive over here for the k hat, and for the k hat we're gonna cross out the kth column and the kth row. Now we can multiply in this direction from top to bottom, and negative bottom to top. Okay, so this is gonna give us 0, and then we have negative this times this. So what is negative this times this? So we have a negative, and then we have 12t, and this is k hat. Okay, so let's write it again. And here you see we have the same expression over here, so we can do 4 minus 8, so that's gonna give us negative 4. Okay, but here, so we have negative 4 square root of 3 t squared j hat, and then here we have negative 12 t k hat. So here this negative and negative, it's gonna turn into positive, right? If you multiply these two. So this is the answer to the cross product of V times A. Now in order to find the AN, the A normal, we simply need to now divide the result by the magnitude of V. And what is the magnitude of V? It's simply 2t squared plus 3. So now this is V times A. And now we can simply divide it by the magnitude in order to get the ATAN, right? write A10. So let's just divide this by 2t squared plus 3, and this is our A10. This is the final answer to the acceleration question. Now let's move on to the next question. So what is our next question now? We have just calculated for the A10 and A normal. Now 1D is to find the curvature of the vector function. Okay, so first we are looking for the formula to find the curvature of the vector function. Okay, if you guys have seen this video where I've explained you guys curvature of a vector function. So here I've shown you guys
the derivative
how to calculate the curvature of vector function. I showed you guys this is the formula to find it. So you can do this over this tangential component over r prime of t, or it's simply the r prime of t cross product with r double prime of t, which we just did over here, because r prime of t is velocity and r double prime is acceleration. So we simply are doing velocity times acceleration, cross product with acceleration, and we just did that in the previous question. So we don't need to do it. We simply need to find the magnitude of it, and then we're gonna divide it by the r prime of t, and then we're gonna find the magnitude of it, which you already did. We simply need to cube it. Okay, so let's go ahead and do it. Okay, so for 1D, what are we doing? To find 1D, we are multiplying d times a and magnitude it, and then we need to do v prime magnitude of v, and then we need to cube it. Okay, so this is what we're doing. So we already have v times a that we found over here. So let's find the magnitude of this. So to find the magnitude of this, we're simply square rooting each component and then square root the whole thing. I mean squaring each component, right? And then square root the whole thing. Okay, and square root of negative is always a positive. Okay, so if you do this, so we're calculating for v times a magnitude, right? So this should give you, so like I explained before, so this 6, it's going to become 36 if you square it, and then this 3 squared, it's going to cancel out with the square root of this, right? So the square and the square root going to cancel out each other. So 36 times 3, that's going to give you 48. So it's going to become 48. Oh, sorry, my bad. It's 108, not 48. Sorry, just confused it with the other one. Okay, so it's gonna give you 108, and then you have plus. So you're gonna do the same thing over here, like I explained over here. So you're gonna multiply 16 times 3 over here, and here you're gonna get 48t squared. Not squared actually, because here it is already squared, and you're gonna square it, so it's gonna become to the power of 4. And now this is 144. It has to be a t. Oh, sorry, because there's a t, so you need to put a t over here. I forgot. And this has to be t squared. Okay. And now again, I explained you guys before, that in this type of problem, you need to make sure that you're gonna factor this out so that you can cancel the square root with this square, right? Okay, so first step is to write this in order. So we're gonna go ahead and do this to the power of 4 square and the number over here. Now this is really difficult if you multiply this and try to find a number. So first, you guys can see this whole equation is a factor of 12. So let's go ahead and factor 12 from this equation. So after factoring 12, so you should be left with 4t to the power of 4 plus 12, because 12 times 12 is 144 and 12 times 4 is 48. and then t squared plus 9, because 12 side 9 is 108. Okay, now what is our next step? So we're not done yet until we get a square, remember? Right. So we need to factor this equation now. So now it's easier. So we can go ahead and multiply a times c, which is 4 times 9. So after multiplying 4 times 9, we get 36. And after adding, we need to find two numbers such that we multiply them, we get 36. And if we add them, we get 12. So again, these two numbers turn out to be 6 and 6. Okay, so R is 6 and S is 6 as well. So now we are going to break this into 2. 6t squared plus 9. Okay, and next again we're gonna treat this separately, this part and this part. We can factor out what we can from in here. So from here we can see that we can factor out 2t squared. So we're gonna left with 2t squared plus 3 inside, and then we're gonna factor a 3 from inside. So we're left with 2t cubed plus 3. So again, taking this equation and these two because they're similar, so they're same. 2t squared plus 3 and 2t squared plus 3. We're left with this, and not forgetting the 12 that was hanging in over there from long time. So 12 looks messy. So 12. Okay. Oh, what am I doing? Hey, what's wrong? Why keep writing it by itself? I wasn't writing, but it was writing by itself. Okay, it's taking forever. Let's just ignore it. Okay, so you need to square root this, and then so here, like I explained before, x times x is same as x squared, just like that. I guess there's a problem with this application. I'm gonna restart and come back. Okay, I'm back. So now we can just write this to the power of 2. Okay, why it's happening again? Okay, I hope it doesn't happen again. So now you need to take the square root of 12. So the square root of 12 is same as 2 square root of 3, and here this square is going to cancel out with this square, so you are left with 2t squared plus 3. Okay, so this is your answer to B times A cross product. B cross product with A magnitude. And then, okay, now our next step is to find the magnitude of B, which we already have from our previous problem. We have 2t squared plus 3, and we simply need to cube it. So now, to find the curvature, so we need to cube it, right? So we have this over here. We have 2t squared plus 3, and we're gonna take the cube root of it. Okay, now we can just simplify things out because this is to the power of 3 and this is 1. And we have, when we're doing the fraction, let's remember if this is like 1 and this is to the power of 3. So what do? So because these two are same, we are going to subtract this, so we're going to do 1 minus 3. So it's going to give you x to the power of negative 2. And since it's a negative, which means this is at the bottom, so it's x squared at the bottom. It's positive, which means it's at the top, but when it's negative, it means it's at the bottom. Okay, so we're gonna do the same thing over here. Okay, so here we have 2, 3 at the top, and when we do 1 minus 3, So we have 2t squared plus 3 and 3 squared at the bottom because it was negative 2 at the top. So this is the final answer to the curvature to 1D. Let's move ahead to question number 2 now. Alright, this is question number 2, and here we are given the surface given by this equation, and we need to find the equation of tangent plane at the point. Okay, again, if you go over my channel, you can see that I've already posted this equation, this video over here where I explain you guys how to find the equation of a tangent plane, where I showed you guys this formula to find it. So let's go ahead and use this. Okay, so this is the 0 where f of x, f of y, f of z is nothing but the gradient vector, which means partial derivative of f with respect to x, partial derivative of f with respect to y, and partial derivative of f with respect to z. So this is what f of x, f of y, and f of z means, and this x0, y0, z0 is the initial point given. Okay, so I was just explaining you guys the notation so you guys don't confuse yourself. Okay, so let's go ahead and find the gradient vector first. So to find the gradient vector, we have this equation over here, which is given as xy plus yz plus zx equals to 7. So first, let's go ahead and find f of x. So the gradient vector, you can find it all together like f of x I hat, f of y j hat, and f of k, f of z k hat, or you can break the components and then write it all together later. Okay, so this is what I'm gonna do because it's easier. There's less chances of making a mistake, so I would suggest you guys do the same thing. So we are differentiating the function with respect to x. It is the same notation as partial derivative of f with respect to x, which means we are differentiating with respect to x. That means all the other variables are treated as constant. So what are the other variables that we have over here? Y and z. So y and z are treated as constants over here, and we're differentiating only x. So we're differentiating only x in this equation. So here, for the first one, we're gonna have x, and we're not gonna have x because the derivative of x is 1. Okay, so it's gonna disappear, and then y, it's a constant, so it's gonna stay over there, and yz, there's no x over here, so this whole thing becomes 0 because these two are constant, so it's 0, and then there's an x over here, so it's gonna go to 1, and z, it's a constant, so it's gonna stay over there. This is a constant as well, so it's gonna become 0 as well. So we have our f of x as, so if we remove the 0, we have y plus z as our f of x. Now, what about f of y? So for f of y, partial derivative of f with respect to y, which means x and z are treated as constants. So here f goes to 1, so we have x only, and here we have z only, and x and y are constants, and this is a constant as well, so the rest is all 0. Okay, so we don't need to write. Now f of z, we're differentiating z only. This time x and y are constant. These two are constant, goes to 0, don't need to write it. Y and z, z goes to 1. This is y, we're going to write it over here. Z goes to 1. This is x. It's a constant, stay over there. And this is a constant by itself, so that goes to 0. So we have f of x, f of y, and f of z over here as y plus z, x plus z, and y plus x. So now, once we have our gradient vector, we can now go ahead and plug this into this equation. So we can write it as this equation. So we need to write first for the thing. This is the equation of tangent plane. Okay. So once we have all these values, so what are we going to do next? So we're going to take the gradient vector that we have. Okay. So we are taking the gradient vector. The gradient vector that we have over here is y plus z, which is f of x, and then we have x plus z, which is f of y, and we have y plus x. And now this is our gradient vector. Okay, now we're going to evaluate this gradient vector with the given point that we have. So the given point that we have is 1, -3, and -5. Okay, so we're going to evaluate it from 1, -3, and 5. So this is x, y, z. We're going to plug in these points x, y, z into this equation. So y is -3, -5 I hat plus x plus z. So that's 1 plus 5. Oh, sorry, it's -5 in the equation. Yeah, it's -5. So it has to be negative over here. So then it's going to be 1 -5 g hat plus y plus x. So this is y plus x key hat. Okay, now this should give you -8 I hat, -4 j hat, -2 k hat. Okay, after evaluating at the given point. So now you can finally use the equation to solve for the tangent plane. So we have equation as f of x, x minus x0, f of y, y minus y0, and f of z, z minus z0. So this is our f of x evaluated at the point, f of y evaluated at the point, and f of z evaluated at the point. Don't forget to evaluate at the point. This is very important. Just don't forget it. Okay. So now we can go ahead and use this equation that I wrote at the top. So let me write it again at the bottom. This is to find the tangent plane. So we have -8 x minus x0, x0, y0, and z0 is the point that you are given. Okay, so you are given this point over here and you're showing the problem. So this is the x0, y0, and z0. So the x0 is 1, and f of y, that's -4, y minus, and it's already negative in the point, so that's -3, which is obviously a positive 3 then. And then f of z, it's -2, and then z minus z0, that's -5, so it's going to become 2 positive 5, and then equal to 0. So this is your tangent plane, equation of the tangent plane, but it's better to simplify it a little bit. Okay, so -8x plus 8, -4y, -12, -2z, -10 equals to 0. So 8, -12, -10. So this is going to be -14. And we have -8x, -4y, -2z. So this is the final answer to the tangent plane. This is the equation of the tangent plane. Okay, next, what is the next problem now? So we just solved for this one. Let's go ahead and find the vector equation of line that passes through this point and is normal to the surface. Okay, so to find the vector equation, first you need to evaluate the gradient at this given point 1, 0, 7. So we already have found the gradient, which is this. Okay, so I'm going to go ahead and copy this gradient that we found in part A. Okay, so I have it over here. So now I am going to plug in this point into this one. So this is x, y, z. So I'm going to go ahead and plug this. Okay, so if you plug it in, so y plus z, y is 7, z is y is 0, z is 7, so that's going to be 7. and then just like that you're going to continue. So that's 8 and this is 1. So you're going to get 7, 8, 1 if you evaluate this point at the gradient 1, 0, 7. Okay, now to find the equation, you're just going to take this point 7, 8, 1, multiply with t, and then write the equation, the point that you are given, 1, 0, 7. Okay, and this is it. This is the answer. This is how you're going to find the equation. What is the vector equation of the line that passes through the point, which is normal. So this is how you calculate for it. Now let's go ahead and move to the third question. Alright, this is the third problem that we have over here, and here this asked us to here we were given this function over here. It says if x equals to u squared, y equals to blah blah blah, find the partial derivative of the function with respect to u and partial derivative function with respect to v. So for this type of function, you always need to draw a tree diagram. Remember, I also taught you guys how to do this, so I'm not going to go over my channel again. I'm just going to show you over here how do we do this, but I actually solved a similar problem over in my channel. If you want to check this out, go ahead and check out the playlist. So to find the partial derivative of f with respect to u, how do we do this? So first of all, you're gonna look at the question carefully. So in order to draw the diagram, alright, so this is our third problem. So here we're given this function over here. We need to find the partial derivative of f with respect to u and partial derivative of f with respect to v. I also solved a similar problem in my playlist, so do check that out. So to find this, what are we going to do? You need to create a tree diagram for this, and here since we need to find a partial derivative of f, so first of all you're going to write f and then you're going to create branches from this f. So check out this function carefully. So this function f is a function of two variables, x and y. Okay, so you're going to write this function f is a function of x and y variable, right? This is the function that I'm talking about. It's a function of x and y variable. Okay, and now let's go ahead and check x. So this x function is a function of one variable only, u. Okay, so we're gonna create a branch, so it's a function of only one variable, u. And what about this y? So this y is a function of u and v, two variables over here. So we're gonna create two branches. That means it's a function of y is a function of u and v, two branches. Okay, now this completes our tree diagram. So in order to find the f of function partial derivative of f with respect to u, so here you're gonna find u everywhere in this tree. So you see a u over here and a u over here. So you're gonna go in direction something like this, and you're gonna write the values. So remember, when we're taking the derivative, we go in this direction. Okay, so we're going to write this partial derivative of f with respect to x in this branch. We're gonna write this top function goes at the top and this bottom function goes at the bottom. Okay, so similarly over here, this top function is gonna go at the top and this bottom is gonna go at the bottom. So f partial derivative of f with respect to x and partial derivative of x with respect to u, and going like this, right? Okay, so similarly over here, so this has to be a function of f with respect to y. And what about this one? So this is y with respect to v, and this is y with respect to u. Okay, it's as simple as this. Next, what do? So we have u over here and over here. So first of all, we have this. So in order to go from this to this, we need to multiply these two. That means, okay, so we're gonna multiply the partial derivative of f with respect to x with partial derivative of x with respect to u. And every time you go in the other branch, you need to add a plus. Okay, now we are in this branch because there's a u as well. We're not done with this. There is u in this branch as well, so we need to consider this branch as well because we need to find partial derivative of f with respect to u. So now in this branch we have f, partial derivative of f with respect to y, and next we have partial derivative of y with respect to u. So this completes our problem, and we need to find the missing things and then plug into the formula, and then we're done with the problem. And now, how do we find partial derivative of f with respect to v? Now we need to look at the branches which correspond to partial derivative of v. So let me take the color green for it. So partial derivative with respect to v, there's only one branch, which is over here. If you see it carefully, only one branch, right? Yeah, so this branch. So oops, just remove the whole thing. Okay, so this branch that you see over here, so this is in the direction we need to go. Here u was in two branches, that's why we wrote 2 times, but here it's only one branch. So we're gonna take this branch and multiply these two values. So we're taking partial derivative of f with respect to y dot product, multiplying with partial derivative of y with respect to v. So I hope this formulas make sense. So let's go ahead and find these values now. So in order to find the partial derivative with respect to x, which means we're going to look at the function f. So the function f that we have over here is exy squared, okay? Exy squared. So we are taking the partial derivative with respect to x, which means we are treating y as a constant. So this exy squared, let's just say it is the same thing as e to the power of 2x, right? And how do you take the derivative of this one? So to take the derivative of this one, it's going to be the same thing. First e to the 2x, and then you're going to multiply by the inside function. So the inside function is 2x, and what's the derivative of 2x? It's 2, right? So this is how you're going to do it. So similarly, you need to follow this. So here you have e to the xy squared. So what is the derivative of e to the xy squared? First of all, it's going to be the same thing, and then you're going to multiply by this inside function xy squared. And remember, we're differentiating with respect to x, which means y is a constant. So yeah, remember that, which means x goes to 1 and y squared remains over there. So this is y squared exy squared. Now we have partial derivative of f with respect to let's go ahead and finish this problem. Partial derivative of x with respect to u now. So we are looking at the function x and we're differentiating with respect to u. So there's only one variable, so that's going to be 2u. Okay, so now we have partial derivative of f with respect to y, partial derivative of f with respect to y this time, not x. So it's going to be the same thing again, and this time x is a constant, so it's going to stay over there. And we need to differentiate y squared, so that's 2y. So let's write it neatly, 2xy e to the xy squared. Okay, let me just do this so you guys don't forget. Next, we have partial derivative of y with respect to u. So we have partial derivative of y with respect to u. Okay, so we have y. Where is the function y? So this is the function y, u minus v cube. Okay, and we need to find we are differentiating with respect to u. That means v is a constant. Okay, So v is a constant, so it's gonna go to 0. So you only have u left. You only have u left, but the derivative of u, since you're differentiating with respect to u, so the derivative of u is 1. So you're left with 1. Now let's put in everything together and find this partial derivative of f with respect to u finally. So let's put in everything together. So f with x is this thing, y squared, e to the x y squared, and then we have x with u, so we have x with u as 2u, and then plus we have f with y, so we have f of y, we got 2xy exy squared, and then y and u, we got 1. So this is the answer to partial derivative of f with respect to u. Now partial derivative of f with respect to v. Partial derivative of f with respect to v. Do we have the things that we're looking for? Do we already have it? So do we already have f with y? Yeah, f with y, we already have it. So let's go ahead and write it. So we already have 2xy exy squared. Now, do we have y with v? Now we have y with u, but not y with v. So let's go ahead and calculate this. Y with v, partial derivative of y with respect to v. So this is the y equation, and we are calculating. So this is the y equation, and we are calculating for v. That means we are differentiating the function with respect to v. So u is the constant, so u goes to 0, and we're taking the derivative of this only. So that's going to be negative v3 squared. So then we can simply multiply this with this. Okay, we got negative 3v squared. So that's going to become negative 6v squared xy e to the xy squared. And this completes our problem.